Hello, viewers. In today's session, we are going to discuss another important topic from three-dimensional geometry, right? And here we'll see a problem in which we have to find the condition for an equation to represent a pair of planes, right? So let us start and let us see the condition that a general homogeneous equation of second degree in x, y, and z, it represents a pair of planes. So now let us consider the equation of two planes as L1x plus M1y plus N1z plus P1 is equal to 0 and L2x plus M2y plus N2z plus P2 is equal to 0, right? Suppose this is plane P1 and this is plane P2. So these represents the equation of two planes. Then the combined equation of the pair of planes is given by P1, P2 is equal to 0, right? So P1 multiplied with P2 is equal to 0. It gives the combined equation representing a pair of planes. So P1 can be replaced by L1x plus M1y plus N1z plus P1, and P2 is L2x plus M2y plus N2z plus P2 is equal to 0, right? So this equation represents a pair of planes. So now any point lying on this plane P1 or this plane P2, it satisfies this equation, right? So this equation represents a pair of planes whose individual equations are given by these two equations, and this equation is satisfied by all the points lying on either of these two planes P1 and P2. So now when we multiply these two factors, then we'll get an equation in second degree in x, y, and z in the form that is ax square plus by square. Here we have ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy is equal to 0, right? So when we multiply these two factors together, then we get an equation of this type, and this equation is known as a general homogeneous equation of second degree in x, y, and z. And this equation represents a pair of planes whose individual equations are given by P1 is equal to 0 and P2 is equal to 0. So now the question arises that if we have an equation of second degree of this type, then what is the condition that this type of equation represents a pair of planes? Right. So here we are not going to derive the condition, rather we'll straight away write the condition in which we have a pair of planes, right? So if we have any second degree homogeneous equation of this type, then this equation represents a pair of planes. If we have this condition, and the condition is that ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0, right? So this is the condition for this equation to represent a pair of planes P1 and P2. And this condition can also be written in a compact form in terms of determinant, and we can write here A, B, C, and then here we can write H, H, and then we can write here G, and here also we can write G, and then we have F and F, and this is equal to 0, right? So if the value of the determinant AHG, HBF and GFC is equal to 0, then this equation represents a pair of planes, right? And we'll also solve a problem related to this topic. So now consider this problem in which we have to show that this equation 2x square minus 6y square minus 12z square plus 18yz plus 2zx plus xy is equal to 0. It represents a pair of planes, right? So to get the condition for representing this equation a pair of planes, we'll compare this equation with this one, right? So if we compare this equation with this one, then we have the value of a is equal to 2, a is equal to 2, then b is equal to minus 6, then c is equal to minus 12, and here the coefficient of yz is 2f, so 2f is equal to 18. It implies that f is equal to 18 divided by 2, that is 9, and then we have 2zx, and here the coefficient of zx is 2g, so we have 2g is equal to 2, so g is equal to 1. 2 divided by 2 is 1, and then we have xy, and here the coefficient of xy is 2h, so we have 2h is equal to 1 because here the coefficient of xy is 1, so here we have h is equal to half, right? So we have the values of a, b, c as 2, minus 6 and minus 12, and here the values of f, g and h are 9, 1 and half. So now let us substitute these values in this condition, and if the left hand side is equal to 0, then this equation represents a pair of planes, right? Or in other words, if the value of this determinant is equal to 0, then this equation represents a pair of planes. So here we have ABC, and we have now 2 times minus 6 times minus 12, then we have 2 times here we have 2 times fgh, f is 9, then g is 1, and here we have half, right? And then we have minus af square, so we can now write minus a is 2, f square is 9 square, then we have minus bg square, b is minus 6, and g square is 1 square, and then we have minus ch square, c is minus 12, and h is half square, right? So now if the value of this expression it comes out to be 0, then this equation represents a pair of planes. So now here we have 2 times 6 is 12, minus minus multiplied together it becomes plus. 12 times 12 is 144, and here we have 2 and 2 get cancelled, so we are left with only 9. Here we have 81, 2s are here we have minus 2 ones are 2, 2 8s are 16. Then we have here 1 square is 1, minus minus plus, so we have 6, and then here minus minus becomes plus, and here we have half square is 4, 4 times 3, so here we have simply 3, right? So now adding 6 plus 3 is 9, 9 plus 9 18, 18 plus 144 is 162, and here we have 162. So 162 minus 162 is equal to 0. So this equation it represents a pair of planes because it satisfies this condition. So now consider one more problem. Here we have to prove that the equation 4x square plus 8y square plus z square minus 6yz plus 5zx minus 12xy is equal to 0. It represents a pair of planes, right? So again, we have to satisfy this equation or this condition, and we'll find out the values of A, B, and C. Here we have C. Then we have to find the values of F, G, and H by comparing this equation with this one. So if we compare this equation with this one, then the value of A is 4, then the value of B is 8, the value of C is 1, because here the coefficient of z square is 1. So here we have 1. Then here we have minus 6. So 2f is equal to minus 6, because here we have yz. The coefficient of yz is minus 6 here. So f is minus 3. And here we have the coefficient of zx 5. Here we have 2g. So 2g is equal to 5. So g is 5 over 2. And here the coefficient of xy is minus 12. And here we have 2h. So 2h is minus 12. So h is minus x, right? So now substituting these values in this equation, the left hand side is equal to ABC. ABC is 4 times 8 times 1. Then we have 2FGH. F is minus 3, G is 5 over 2, and H is minus 6. Then we have minus AF square. A is 4, F is minus 3 square, minus BG square. B is 8, G is 5 over 2 square. Then we have minus CH square. C is 1, H is minus 6 square. So this is 4 times 8 is 32. Here we have minus and minus plus, and this 2 and this 2 get cancelled. 5 times 3 is 15, times 6 90 here. Here we have 9 times 4 minus 36. Here we have 25. Here we have 4. This is 2, because we have 8 times 25 by 4. This is 4 times 2, 8. So here we have minus 50. And then here we have minus 36, right? So now this is, we can add these two numbers. We have 2, this is 12. Then we have 6, 6, 12. Then we have 5 plus 3, 8 plus 3, 11, and 12. So this is 0, right? So here also we have got 0 in the right hand side. So this equation satisfies this condition. Hence this equation represents a pair of planes.